Okay, I'm going to go ahead and go over one of the practice exams. Now I'm actually going to take the exam as if I were taking it in class. I will, however, explain all the steps that I'm doing, but I will go a little bit faster so that I can do this in less than 15 minutes. Okay, so question 1A. Now x is going to approach 0, so it's a good idea to just plug in 0 and see what you get. So you get e to the 0, which is 1, minus 1 is 0. On the bottom you get tan inverse of 0, which is 0. So according to L'Hopital's rule, we have 0 over 0, which allows us to take the derivative of the top and bottom. So when you differentiate to the top, you get 2e to the 2x. On the bottom, you differentiate tan inverse, which is 1 over 1 plus x squared. I should probably clean that up a little bit, but it's not really necessary. If you plug in x equals 0 up here, you'll get 2e to the 0. That's just 2. Down here you get, 1 plus 0, 1. So this whole thing ends up being 2. Alright, let's move down to the next one. Alright, this one actually is supposed to say 2x, not 2 over x, but 2x. Now if you plug in infinity, I guess, again, can't really plug it in, but if you did, you get 1 minus 0, which is 1, and then this is infinity. So you get 1 to infinity, which is an indeterminate that we worked in class. Now what you're going to do is you're going to let y equals the function. Then what you're going to do is you're going to take the natural log of both sides. Now when you do that, you get this. Okay. Now if x goes to infinity, you'll get infinity, and you get the natural log of 1, which is 0. So you get infinity times 0. That's another indeterminate. Now at this point, what you want to do is try to get it so that it's infinity over infinity, or 0 over 0. It's extremely unlikely that you're going to bring the natural log down to the bottom. So what we're going to do is we're going to bring the 2x down to the bottom. So we're going to get 1 over 2x. So now if x approaches infinity, you'll get natural log of 1, which is 0. And then as x goes to infinity, 1 over 2x goes to 0. So you get 0 over 0. That allows us to use L'Hopital's rule. Now the derivative here is going to get a little bit complicated. So first, we'll get 1 over 1 minus e to the x, e over x, sorry, times the derivative of 1 minus e to the x. Wow, 1 minus e over x, which is a positive e over x squared. So I'll let you check that on your own, but that's what you get. Over, now when you differentiate this, you will get negative 1 over 2x squared. So we're going to let you check that. Still limit x goes to infinity. Now, let's see what cancels here. We got the x squareds cancel, and this cleans up. Let's see, we have a negative here, and this 2 is going to come up top. So I'll let you check this, but you will get 2e, negative 2e, over 1 minus e over x. Now as x goes to infinity, the bottom goes to 1. This whole thing ends up going to negative 2e. Now, we know that the natural log of y approaches negative 2e, which means y will approach e to the negative 2a. Because in order to get rid of this natural log, we have to exponentiate both sides, and that's where this e comes from. So there's your answer. Alright, moving on. So differentiate this. It's just one long chain rule. Derivative of sine is cosine. Leave the inside alone. Then we're going to differentiate cosine inverse. That's negative 1, 1 minus 2x minus 1 squared, times the derivative of its inside, which is 2x minus 1. Derivative is 2. Alright, that's Oh, missed the 2. There's the answer to that one. Okay. Let's see if I can... There we go. Alright, moving on. Now there's going to be one integral of each, at least one. This one, you notice you have a tan inverse, and 1 over 1 plus x squared is the derivative of tan inverse. So this is a basic u substitution. So let u equal tan inverse x. That means du is 1 over 1 plus x squared dx. Alright, and so everything gets substituted and taken care of. You end up with just 1 over u du. That's the natural log of u plus c, and then substitute back in what u is tan inverse. Alright, and that's that one. Alright, this one is a little bit harder. Now I said that this is a two-part problem, try integration by parts first. Now, you have to have a u and you have to have a dv. Now, the dv is going to be unlikely sine inverse. So I'm going to let u equal sine inverse. And dv is going to be 1 over x squared dx. So now du is 1 over 1 minus x squared, root 1 minus x squared dx. And v is going to be negative 1 over x dx. Nope, sorry, no dx there. That way it works. Alright. So integration by parts, first step would be uv, so negative 1 over x, sine inverse of x, minus v du. So multiply these two together. Now there's a negative here, so I'm going to bring that out as a plus. 1 over x square root minus x squared dx. Now this is the second method. Now this is a trig sub. So we're going to have to go ahead and go through the trig sub process. So this part here is done. Alright, here we're going to let x equal sine theta, which makes dx equal cosine theta, d theta, and the square root of 1 minus x squared is 1 minus sine squared, which after you clean everything up, you get cosine. So it's going to turn into 1 over, now the x is sine theta, this portion here turned into cosine theta, and then dx, which is cosine theta, d theta, that all cleans up to be, the cosines are going to cancel, leaving 1 over sine, which is cosecant theta, d theta. Now, the integral of cosecant theta, which if this showed up on the test I would give it to you, but it's going to be the natural log of cosecant theta minus cotangent theta. So I'm going to have to use this space here down here. So what we have, well now we have to get back in terms of x. So this is when we would use our triangle, put in our theta. Now recall that x was sine theta. So that means we have x, so opposite over adjacent, and then this is 1 minus x squared. Alright, so this is going to turn into the natural log of, now cosecant is 1 over sine. Sine is x over 1. So cosecant is 1 over x. And cotangent, the opposite of tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. So final answer would be negative 1 over x sine inverse x plus the natural log 1 over x 1 minus x squared. Alright, so I know that was a longer problem, but that's how you do it. Alright, moving on. I'm going to go ahead and delete this, so if you need to look back at it, just rewind the video. Okay. Now this one is just the basic powers of trig functions. You look for the odd one. Sine is odd. So what we're going to do is we're going to pull out one of those signs. We're going to bring it out to the back. So now our goal is to let u equal cosine, because then du is negative sign. Well, sine, negative sign. I'll take care of this. So I need to change this in the cosines. So the way we're going to do that is we're going to rewrite this as 1 minus cosine squared, that's sine to the fourth, cosine to the fourth, cosine x. Oops. Sorry. Sine x dx. So we're going to let u equal cosine. So du is negative sine dx. So all of this is going to turn into negative 1 minus u squared u to the fourth du. Now this negative is what this came from right there. That negative. Alright. So if you clean all of this up, let's see, you get 1 minus 2 u squared plus u to the fourth u, and then distribute that, you get u to the fourth times 2u to the sixth, u to the eighth, u, and not, well, we'll get minus, and then 1/5 u to the fifth minus 2/7 u to the seventh plus 1/9 u to the ninth. And then since u was cosine, you can go back and plug in cosine. So 1/5 cosine to the fifth minus 2/7 cosine to the seventh plus 1/9 cosine to the ninth. And then you can throw in your plus c down there. Alright, we're going to move on to the next one.